And now for our technology-focused session, Natural Innovation. The goal today is to highlight current and future innovations in natural refrigerant technologies. And I'm pleased to introduce our speakers, Diego Orsucci, HVAC&R Sales Manager for Brazed Fusion Bonded Heat Exchangers within the Energy Division of Alfa Laval, Roman Rathsack, the Senior Global Business Development Manager for BU Brazed and Fusion Bonded Heat Exchangers within the Energy Division at Alfa Laval. Piotr Jabłoński, Area Academy Manager with Area Cooling Solutions, and Patryk Majerski, CO2 Project Manager with Area Cooling Solutions. So with that, I am going to hand things over to Roman and Diego to tell us a little bit more about what's going on within Alfa Laval.
Thank you very much, Morgan, for the kind introduction, and thanks NASRC to having us here today and for the opportunity with this great event. So welcome everyone, and thanks for joining our discussion today. Roman and I are very pleased and proud to be here, part of this organization, and we would like today to take you to a little journey on how Alfa Laval is trying to advance sustainable solution, for sure with a strong focus on heat exchangers related to natural refrigerant and supermarket and commercial refrigeration, but also giving you some highlights of some breakthrough technologies we're working on our roadmap to net zero. So since somebody of you might have heard the name Alfa Laval for the very first time, let me just give you a brief introduction of who we are and what we do. Morgan, next slide, please. So we are a Swedish multinational company, and in every technology we develop and in every market we play in, we have a strong focus and commitment, not just on a business level. So not just trying to supply our customers and partners with the most efficient solution, but also keeping our planet in mind. So using the resources that we have at the best. That's why also being part of the NASRC community, for us, it's a full completion of our long-term goals when it comes to efficiency, sustainable, and net zero goals. Next slide, please, Morgan. And how we do that? Well, we do this through a lot of technologies and products. And of course, we don't want to go into the details today, but just interesting for you maybe to notice that you can find Alfa Laval very close to you in every daily life application. So it might very well be that an Alfa Laval product will be at the grocery store where you do grocery tonight. For sure, it might be into the chiller that is cooling the office where you are working today. And maybe you are on a cruise ship on the Caribbean, and you will find a lot of different product of Alfa Laval in that environment as well. So as you can understand, everything we do has an impact on the energy, on the efficiency, and on sustainability in our world. Next slide, please, Morgan. And of course, as I mentioned before, we are a multinational company. We have a strong presence everywhere. And this is important not just because we can reach and we can reach our customer, be close to our customers and partner everywhere, but also because being present all around the world will give us the knowledge and the experience and the update with every trend and legislation and new regulation that we can then bring into our R&D and be sure to develop the right technology at the right time. So we'll be today ready for the world that is as it is, but we would like to be every day ready also for the world of the future. Next slide, please, Morgan. And why are we here today? Well, NASRC and you all and we are here today for a common goal, right? So try to lessen the impact of refrigeration with the widespread adoption of natural refrigerants. In general, what we are all aiming for is try to reduce every environmental impact and try to use the resources that we have in the best way when we use them and also in the future. So as you can see, Alfa Laval is operating daily with our sustainable cornerstone. And so before leaving the words to Roman to get into the details actually of our heat exchanger for supermarket, the commercial refrigeration, and their relationship with the CO2, ammonia, or propane, let me just leave you with the message of our energy division president when it comes to our roadmap to net zero. So Morgan, if you can play the little video, thank you. Maybe easy. Wait a little bit. Let's see if we can make it.
I'm having the
Do you
same
want
issue
me
I
to
was
try?
having, Aisha. Yes,
can-
I didn't realize it wasn't showing for you, so that'd be great, Diego. Sorry about that.
No problem. I can share my screen and I can play the video here for you guys. I hope you can see it.
Joining me now is the president of the Energy Division, Thomas Möller, to tell you more about our sustainability strategy and how we plan to help our customers on the road to net zero. Hi, Thomas.
Hi, Lily. And getting to the net zero by 2050 is really the biggest challenge we have ever been facing. And failure is not really an option here. If we look at how much energy we are producing that goes to waste, it's never really actually being used for the purpose it was produced. We produce a lot of energy from fossil fuel still, and we produce and use and throw away things in a way that is not sustainable at all. So we have to rethink how we do things, and in Alfa, we group these as energy efficiency, clean energy, and circularity.
We made it work, and then I'll give it back to you, Morgan. So now the word is to Roman.
Okay. Yes. Hello. Thank you. So it's a pleasure showing you the picture or our global view of heat exchanger being used in natural refrigerants. So let's get started with the ammonia. Can you click, please, or Morgan? So ammonia has a very good enthalpy of evaporation and is being used a lot for a long time in processing industry. What you cannot see on the right side is that we are selling a lot semi-welded gasket heat exchanger into this application. And there's a benefit in this application. There's a huge investment. The CapEx is very high, but when you have such installations like this huge ammonia tank, you can use the point of consumption in the factory wherever it is, and you have then a semi-floated system, and this installation can be also adjusted and expand later on if needed. And this is also with our heat exchanger. You can enlarge the number of plates, and you can modify the stuff. What we see also very often is a combination with CO2 on the lower temperature side. So having then a CO2 system, for instance, in ice rigs. CO2 has a much better evaporative coolant than a normal brine system. And this is very good for the efficiency of the whole system. So you can use smaller pipe diameters, less flow, smaller pumps, so a much better efficiency. What we see also on the market of ammonia is that the smaller ammonia chillers becoming more popular in Europe for the moment. And this is a trend. So up to 85 ton. It's a plug-in chiller in industrial processes, which is very interesting into the market. So we're selling their evaporator, huge evaporator with a specialized distribution system inside. And this is an interesting business case. What we are also selling, this compact foil stainless steel heat exchanger, is within the application for ammonia compressors as oil cooler. So this is for a long time also a business case. Can you click how you have done this already? We are already on the CO2. CO2 has been already enlarged. So when it comes to CO2, CO2 has a very interesting volume-related cooling capacity. So smaller installation, and yeah, in the market, less barriers. I mean, one is for supermarket, it doesn't smell. So there's no problem with this kind of discussions. But CO2 is transcritical, so we are working very much outside the saturated liquid curve. We're working with 2030 psi. So all components in short CO2 systems need to be prepared for high pressure, so that we have also developed our heat exchanger with a special flange on the high pressure side. And this is something that you need to know. And also the off pressure on such system can be up to 1015 psi. So nevertheless, there's a huge entrance in the hyper and supermarket with booster systems. But we see also, and we have heard the last days a lot about ejector systems. And this ejector systems is giving such systems with CO2 a huge opportunity in ambient temperature above 81 Fahrenheit. So you can use more and more chiller within the procession air conditioning business. And we see that this going also in processing industry and the logistic and bigger capacities. So the request for us is having much bigger evaporator. And for this, we have recently launched the AC540. This is a floated evaporator up to 870 psi, and we developing further on bigger evaporators for this kind of application, growing application. So I've been talking a lot about air conditioning process chiller, but you can imagine we have, as we are working on the transcritical mode, we have also a very high discharging temperature and a huge enthalpy, and we see this is being used more and more into the market for heat pumps applications. So CO2 is becoming more and more interesting for heat pumps. And we see also whenever there's a heat reclaim in industrial processes, a heat pump option is being very much used with CO2. Next click, please. Okay, about propane, we have a lot business for a long time with supermarkets and small discounters. There's been used cabinets with a small condenser on top of this, and each of these cabinet is being connected with a water loop system for heat reclaim later on. And the refrigerant inside is propane. So when you're going in the supermarket, most likely there's propane with a charge limitation about 150 gram, and therefore we have developed a small heat exchanger with really small ref charge volume. This has been now enlarged to 500 gram, and what we see in parallel, at least in Europe, is that the whole residential heat pump market is going to propane. So we're developing, and we have already started to develop a specialized heat exchanger with all our branded features for this application. And the same trend goes to commercial heat pumps as well. So we're seeing also a big trend in propane heat pumps. Can you click on the next slide, please, Morgan? So this is a typical booster rack system within commercial refrigeration. It's really compact, and we see a really strong growth because you can replace an existing HFC, HFO system. This is really, really compact. And yeah, we can support easily different temperature levels on all these cabinets. You see the low temperature, the medium temperature level. And what we are selling mostly in these systems is the heat, the gas cooler, which is on the high pressure side. We need pressure about 2030 psi for this. And we're selling also a lot of suction gas heat exchanger. This is not only for protecting the compressor, it is also to stabilize the discharging temperature and to stabilize the efficiency of the whole system. And yeah, what you also can see, there's an air gas cooler, and this air gas cooler is quite very often, of course, our liquid gas cooler. And what we see very often nowadays is that such system is combined with a heat pump and not to use really the existing energy. And we have a good temperature on such systems, and this can be used for heat pumps. Okay, next slide, please. Our challenge have been really, yeah, this frame has been needed for the high pressure, and we have developed for the high volume market new heat exchanger without frames. So having a smaller footprint and really having a smaller cost on this. So to be really ready for this high volume market. When you go on to the next slide, please. So this has been answered by the AXP82. This is a frameless heat exchanger going to 2030 PSI. It can perfectly work in this transcritical operation. There's a lot of cost savings because we can avoid this frame. And we have a lot of special features. We have a smaller pressing depth, better efficiency. We have flow around the port. We have enlarged the brine side, the water side port diameters. So we can use this in a much wider range. And one important thing is really that the thermal fatigue and the pressure fatigue is much better than on the similar duties with frames. So only to give you an indication, the pressure fatigue is 2.5 times better and the thermal fatigue is 3 times better. And this is also very interesting for cascade systems for environmental simulation. It's really a strong heat exchanger. Okay, next slide, please. So I would like to summarize what I have said to you about our heat exchanger. Looking on the left side of the copper braze heat exchanger, we have the CBXP line, which is then for 1300 PSI, and followed by the AXP line. This stands for advanced extremes pressure up to 2030 PSI. And in the middle, you can see this AXP82 without frame. And this is then for subcritical and transcritical CO2 systems. Perfect. In the middle, we have our Alfa Nova product line. As I mentioned before, ammonia, oil cooler, and the bigger ones is then the evaporator for this upcoming ammonia chiller business. On the right side, you see our product portfolio for semi-welded heat exchanger. This is for a long time into the market, but we have developed these products more for higher temperature on the condenser side, for better lifetime on the gasket, and also for much better efficiency and all these branded features that you can see also on our internet page. Okay, that's from my side. We have now a film of Madeline Gilmore. She is the head of our clean technology and vice president, and it's about Alfa Laval clean energy goals. Thank you.
Diego, I'm going to have you play this video again, if you don't mind.
I can do that, no problem. I get familiar to it. Let me just share the video for you all.
Madeleine, as the VP of our Clean Technologies, could you tell us a little bit more about Alfa Laval's clean energy goals and how they can contribute to a more sustainable future?
Yeah, absolutely. So what we're seeing is a rapid transformation of the global energy system to reach net zero by 2050. And what we have to remember is that there is no single or simple solution to get there. It's a combination of technologies to decarbonize both heat, electricity, chemicals, and fuels. Half of the emission reduction we need by 2050 will come from the clean energy technologies that are today in prototype or demonstration phase. Yeah. So what we need is to sort of deploy, we need to scale these solutions, and we need to make them commercially available as soon as possible. And here at Alfa Laval, we already have a wide range of products that can enable this transition, both from advanced heat transfer technology to separation. But we're only scrapping the surface of what we can do. So together with our customers and partners, we are working on accelerating this transition to clean energy.
Okay, Morgan, so back to you after Madeleine's message. And we can go at the end of our presentation. And as Madeleine said, we're all here together. It's not just about one single product or one single industry. And that's also why we're here with NASRC, right? Where we're all working for the same goal and commitment here. And so what we would like to do is to leave you today with 3 slides about this partnership to advance sustainable solution and innovation. And we show you some real cases of what we've done and our experience. So the first one actually is very related to the supermarket, and as Roman has mentioned, it's very common, especially in Europe, to have these propane heat pumps. And this is an example of something that we've done with our partner, a thermal design provider in Germany, and where that deployed a propane heat pump for a supermarket in Switzerland. Basically, the combination of the two made, of course, possible a future-proof solution with the use of propane, so no need to change for the next upcoming years. And of course, the heat exchanger of Alfa Laval has allowed this system to actually have a very high efficiency and a very low pressure drop. So the energy consumption has been optimized and reduced on the pumping capacity requirement. And this is all, if you can think about it, it's all about reducing the carbon footprint and the CO2 emission in the space. So it's not just a natural refrigerants application, but it's also good for the environment and to reduce the environment. So definitely a positive impact with this experience. And if you can go to the next slides, Morgan, we would like to finish today with two experiences and two partnerships that we've done, which are not strictly related to the heat exchanger and its efficiency, but is really about what we're doing to commit to make the world a better place. So the first one that you see here is actually about all circularity. So we're not just using the heat exchanger at maximum efficiency while we're using the heat exchanger, but also at the end of its life. So we partner with Stena here in Sweden, and with this company, we're trying to recycle as much as material we can at the end of its usage. So you can think about this one. It's a very much reduction of the carbon footprint. We're using the resources that we can as much as we can, and not just at the beginning of the life of a heat exchanger, but also at the end of its life. And the third one, actually, that we're very proud of, and it's the last slide for today, Morgan, unfortunately. But it's again, just to reinforce the message of our roadmap to net zero. It's the world's first carbon neutral heat exchanger that we're aiming to release by 2030. With the partnership with SSAB in Sweden, which is our supplier, one of our suppliers for the stainless steel. This material is done with completely fossil-free. So the CO2 reduction while the stainless steel is being produced and will be produced are very low. You can think about a reduction of over 40% of CO2 emission. And not to forget that also the gaskets are made of recycled material. And of course, heat exchangers so environmentally friendly will be also very, very easy to recycle at the end of its life, without thinking about all the energy efficiency and the energy saving that this heat exchanger can give then into all the processes and industrial processes or commercial processes where it will be used. So we just wanted to give you a highlight of how Alfa Laval is moving forward, not just with the heat exchanger and natural refrigerants, but also as a company itself, moving to our net zero goals. And again, this is the last one from us today, unfortunately. You can definitely check on our website more experiences like this or business cases. But again, we thank you and we hope you enjoy our time together. We gave you some food for thoughts and some information for your future needs. So maybe Morgan, if you want to leave the last slide, please feel free to reach out to Roman and myself. Our emails are here. You can also visit our booth. And again, thank you all, and thank you Morgan and NASRC for having us here today.
Thank you so much, Diego and Roman. That was a great presentation. And Diego, thank you for stepping in with the videos to save the day.
No problem.
We've got a couple of questions that have come in. So the first question is just about your sustainability goals, which I know you were just talking about. So we'll dive right in. If Alfa Laval has any sort of zero emission CO2 goals or carbon neutrality goals that you'd like to highlight.
Mm-hmm. And you can also find detailed information on our website about that. But we are moving to be net zero by 2050 and carbon neutral by 2030. So we already started our path. These partnerships that you see here online and on the slides are part of it. So we're working already for our scope 1 and 2, and we're aiming to be net zero by 2050. So again, there is a very detailed link on the website. So if they want to reach us with the email, we can send the link, which is talking about all the steps that we are taking for that.
Wonderful.
Sure.
The next question is about the EPA SNAP approval. So the question is, has propane use in heat exchangers been approved by the EPA SNAP program? And if so, does SNAP require any charge size restrictions and or use restrictions? Do you have any insights on that?
Roman, maybe you
I'd
will.
like to take this question. I mean, I mentioned before that there is for certain application charge limitations, and we have developed also the heat exchanger corresponding to this charge limitation. But it depends on where this heat exchanger system is located and which kind of certification is needed. What we have seen in the market, to jump a little bit out, we have seen that double wall has been requested for heat pumps in Europe, and the market went out of this double wall and is looking more for efficiency and for having a better productivity. So we're selling a lot our heat exchanger without a double wall. So propane is becoming more and more popular, and this question is not 100% being answered, but please send me this question and we can cross-check the limitations and what is the restriction on it. Yeah.
Wonderful. The next question is just an opinion question. What do you, as a supplier and manufacturer of this technology, believe that will need to be done to help the industry accelerate the implementation of CO2 solutions? What can the industry do to support the advancement of CO2?
That's a very good question. Thank you, Morgan. Well, what we're trying to do and what we think is that we are committed and we need to play our part in closing together the gaps that are today here in the market. And when we understand that, of course, supply chain is also one of those. So what we as Alfa Laval are doing, of course, is try to put investment on extending the capacity, and also, of course, being able to have multiple different factories for the brazed heat exchanger around the world. We will, of course, bring in more closer where the markets are. Today, of course, it's immediate how we think that Europe is the biggest customer, or where are the biggest partner for Alfa Laval when it comes to CO2. But USA is coming very fast. Yeah. So that will be in our roadmap for the future to bring that closer and to be able to supply those heat exchangers quickly also for this application, because we know that that's a little gap that we have today, right? So that's our commitment for sure.
Fantastic. I think we have time for one more question. You know, you mentioned that heat exchangers can be found throughout many different areas within a supermarket. Could you share some examples of how heat exchangers can be utilized for folks on the line that could use that extra context?
Yeah, I can answer this question. For instance, this what I mentioned, this gas cooler, which is really on high pressure. And we're working with this 2030 PSI and 110 degrees maximum discharging temperature. So this heat exchanger is giving a huge benefit when it comes to heat reclaim. And this is a much higher temperature level than what you have with HFC, HFO. So this is one good example. And when it comes to suction gas heat exchanger, this is also to optimize the whole system. So the combination of this is two examples, right?
Wonderful. Thank you so much. Well, great. We really appreciate you both taking the time to share some information about this. And I do encourage folks on the line to visit Alfa Laval's virtual booth to learn a little bit more about this information. And with that, I am going to pass things over to Area Cooling Solutions, Piotr Jabłoński and Patryk Majerski, to share a little bit more about what they have coming down the pipeline.
Thank you, Morgan. I already shared my screen. Is it visible for you?
Yes, thank you.
Great. Hello, everyone. My name is Piotr Jabłoński, and I am manager of the Area Academy in the company Area Cooling Solutions. And today I will present you our iCool CO2 units, which are energy-efficient, low GWP refrigeration devices for commercial cooling applications. Today with me is Mr. Patryk Majerski, who is our CO2 project manager. Patryk is a designer of these units and has got field experience because he's making the startups of these units. And Patryk will be here especially for the Q&A session. So if you would like to, we can dive into some details together. So yeah, let me start with the quick introduction about our company. We are Area Cooling Solutions, and we are on the market since 1986. Our main values are the innovation, sustainability, and service. And for us, these are not just the empty slogans, but we try to prove them with everything we do. We develop the innovative solutions. We've got over 12 years experience in inverter-driven applications, and we also develop our own remote control and preventive maintenance systems. We design and manufacture sustainable solutions. In our offer, you can find solutions for all types of refrigerants, including natural ones like CO2 and propane, but also low GWP A2L types. And last value, the service. Support of our partners is very important for us. And therefore, we developed the Area Academy, which is our training center, and the Green Tech Hub, which is a competence center for CO2 and inverter technology. Taking information about our production, all of our units are designed and manufactured in our European factories. Because for us, the quality comes first, our units are certified by German TÜV. Right now, we are entering the US market, and we are during the process of implementing the UL certification, which we aim to complete in first quarter of 2023. This year, in July, we launched our second manufacturing facility in Poland with expansion of our manufacturing potential by additional 7,000 pieces per year. What we actually do? We manufacture refrigeration units for commercial applications, but we also manufacture the subcontracting units, which are the sub-assemblies and custom-built units for special projects. But we are also a distributor of the compressors, components, and controls for the refrigeration and air conditioning and heating, ventilation applications as well. But today, our main focus are our own manufactured units from the iCool product range. And you need to know that every iCool is based on the inverter technology. That's why I would like to explain you how does it work and what are the benefits of this inverter technology. This is crucial, especially today, when we face the rapid increases in the energy costs and when the food and commercial sectors are looking for energy-efficient solutions. When we look at this chart and try to compare the inverter solution with a standard solution, we can see that the standard on-off unit works all the time with the same speed, the same capacity, and consumes the same amount of energy. The performance of the standard unit is based on repeating the cycles on and off. The inverter solution always adapts the capacity to the current demand of the installation. We can reach the set point much faster with going to the high frequency and the high speed of the compressor, and then being close to the set point, we can decrease the capacity and work fluently without often starts and stops, constantly adapting the current capacity of the unit to the exact need of the installation. And in inverter technology, when we decrease the capacity, we also decrease the energy consumption, and it is very important for us. So where exactly are these energy savings? First of all, in this better load matching, I explained, but also in less cycles on and off and softer startups, which also makes life of the compressor longer. But also we've got some indirect energy savings, fewer defrost cycles, thanks to less using the electric heaters on the evaporators. We measure, because it's not only the calculation, but we've got some measurements, and we see the bills for the energy, that with inverter technology, we can save even more than 35% versus standard on-off technology, with a payback even less than 1 year. But of course, this payback depends on the current energy cost in each state. I already explained the inverter technology, which is our field of expertise, because we've been developing inverter units since 2010, with right now over 12,000 iCool units operating in various applications worldwide. But our main focus today are the iCool units made for the CO2 refrigerant. CO2 is a natural refrigerant with low environmental impact, and it is very in line with our value to develop the sustainable solutions. First, initial design concepts of iCool CO2 we completed in 2016. We made some first calculations, concepts. We have built the first prototypes, which was tested in the laboratories, then on the field tests. Finally, we started the mass production. And right now, our current portfolio contains 6 CO2 models, working both for medium temperature and low temperature applications. I would like to now present you this product portfolio, iCool CO2, and what are the features. First of all, designed for natural refrigerant CO2 with global warming potential 1. Of course, these units are in iCool product line, which means energy savings thanks to the inverter technology. The plug and play, because the units are compact, low weight, and very well equipped. So we mainly just need to connect the expansion valve, the evaporators, of course, make the parameterization and the startup, and low noise. What is more, our units have got advanced control and safety automation and remote control system, our own designed remote control system included in standard. When we look at the capacity portfolio, we see that currently we've got units with a capacity in medium temperature range up to 102 BTU per hour for the cooling applications, and in low temperature range up to 30,000 BTU per hour for the freezing applications. But our R&D engineers are currently working on exceeding this product range. The first UL approved CO2 unit, because I told you that we are during the process of entering the US market, will be a model with a capacity 51,000 BTU per hour, and we aim to have it available in first quarter 2023. Where can we apply these units? As I said, we designed them for commercial applications like food sector, retail, but during this summit, we talk a lot about solutions for the supermarkets. And the supermarket is one of the most important target applications of our iCool units, because we believe in a concept of decentralization. We can, instead of installing a big rack system with multi-compressors, which in case of any failure can result with possibility of losing the cooling effect in the whole application, we can divide this whole cooling demand into the bigger quantity of smaller units, which results in a more precise regulation and increased operational safety thanks to the redundancy of the cooling system. As you can see on these graphics, where iCool solutions, our iCool units can supply the whole supermarket needs. We can supply the cooling cabinets on the market, the freezing cabinets, the cooling chamber, the freezing chamber. Our units have got also the heat recovery option, so we can as well cover the heating needs of the market, and whole performance of this system is managed by our own remote control and parameterization preventive maintenance systems. I would like to now present you some additional features of our IQ CO2 units. First of all, the low noise. We can for sure say that we are a good neighbor because our units are designed to be extremely quiet even at high-speed operations, thanks to the optimized parameterization of the inverter to avoid vibrations and high noise frequencies. We use also large diameter EC fans with speed regulations, which can turn at the very low speed and very low noise level. And we also provide the efficient soundproof insulation on every wall of the compressor compartment. On this photo, you can see this insulation on the inside part of this door. And we've got also the insulation on the compressor. So our units are really low noise. Another feature, remote control, which I said that in our CO2 units is in standard, and it's our own system designed by our engineers, which provides the remote diagnostics with the visualization of the monitored values and eventual alarms, but also in the opposite direction, the possibility of parameterization and changing the parameters remotely. Right now, we are working on the preventive maintenance systems. Another option, which is a standard option for our units, is a heat recovery. I think that this is very important, looking on the energy efficiency and the sustainability, because we know that every cooling unit provides the cooling effect, but it also extracts the heat in the high pressure, high temperature side of the system. So it's very reasonable and efficient to reclaim this heat and using, for example, for the processing hot water and central heating needs. I need to say that our heat recovery system is very efficient and innovative and, let's say, complete, because we've got a heat exchanger already built into the device, and we've got the management of the whole heat recovery process made by our unit, including the smooth regulation of the reclaimed heat. I think that heat recovery is important, especially for the CO2, because it's a high pressure, high temperature refrigerant, which provides a lot of energy that could be saved to decrease the cost of the heating energy and to save some costs and make the whole process more efficient. So I invite everyone to use the heat recovery because it's very reasonable. We've got also some benefits for the contractors. Our units can be easily selected in our own selection software, which is published on our website. Easy installed because the units are plug and play, compact, and low weight. What is more, we provide the easy commissioning thanks to the fact that every unit is 100% tested before the shipment and pre-configured in our factory. And finally, easy to service because we provide the wide access to each component and remote control system in standard. Right now, to present you some examples of the reliability of these units, I would like to present you two case studies. First one presents the recordings from one freezing chamber where 3 cooling systems were installed. In this cooling chamber, in this freezing chamber, the set point is -11 Fahrenheit degrees, and the critical temperature point, which shouldn't be exceeded to keep the good quality of the storage product, is +5 Fahrenheit degrees. We can see that previously there was installed there the on-off solution based on the HFC R404 refrigerant, which exceeded this critical temperature very often. Then it was substituted with another CO2 solution not made by our company. And we see in the recording, because all three recordings are from exactly the same shop, we can see that critical point was exceeded also quite often. And right now, in this application, there works our iCool CO2 unit, which provides the temperature stability inside this freezing chamber, even at high ambient temperatures. And regarding high ambient temperatures, I would like to present you the second case study, which presents the reliability of our unit even during the heat waves. Because all of our units are designed for 110 Fahrenheit ambient temperature, thanks to the integrated oversized gas cooler. But in this example, we can see a recording from summer 2021, where the unit worked seamless and without any alarms. We can see here the fluent operation without any alarms and stops, even at 117 Fahrenheit degrees. Also, this summer 2022, quite similar situation was repeated, and units worked without any special problems. But of course, it doesn't mean that we approve the operation above the maximum point of 110 Fahrenheit degrees. As I said in the beginning, one of our values is service and support. And I think that it is very important, especially regarding the CO2. I know that in Europe, we've got already quite well experience with this refrigerant, but for the US, we see that it's our mission to help in this transition and to provide the sufficient training. And therefore, we developed our ARIA Academy, which is our interactive training and support center. We provide the hands-on trainings and the virtual trainings, but we've got also our website, which I invite you to visit, ariacooling.com/ARIA Academy, where we publish some online materials like digital training materials, where we provide some animations and videos, but also we run some kind of a blog, a script of refrigeration knowledge, when we publish articles about basic refrigeration knowledge, but also about some newest technology innovations and some new technologies. So I invite you to visit our ARIA Academy. And as an example of the content which we publish, I would like to present you our newest material, which is available to download for free at our website. It's our virtual showroom based on the VR, virtual reality technology. We've got two versions. First one is for the 3D goggles, which Daniel and Morgan even tested at the Chilventa, and I remember that it was quite interesting experience for them. But we've got also the PC version, which everyone can download and use on your PC. We made this VR experience especially for the training purposes, because it will help you to better understand the inverter technology and innovations inside our iCool units. It contains two main experiences. In the first one, we can check each component. We can select the component, slide it out from the unit, make a zoom, rotate it, check how it is built, and turn on the voiceover description to better understand how it works. But we've got also the second experience, which is the explanation with visuals of the whole refrigerant flow through the unit. We present the exact flow through each part of this unit, stage by stage, with deep explanation of thermodynamical changes and phases of the refrigerant at the current stage. And thanks to it, we can better understand how this unit really works. So I really invite you to visit the ARIA Academy website and check out this tool. In the very end, I would like to share with you some contact data. As I said, we are right now beginning to enter the US market with creating sales, technical support, and training center there. But meanwhile, if you've got any questions regarding our products, our technical specifications and purchasing conditions, please feel free to contact our CEO, Mr. Joseph Ventura, with mail address given here, or our US phone contact with the phone number given here. So from my side, regarding the presentation, that is all. And now me, together with Patryk, invite you to ask some questions. And yeah, I hope we will also catch up later. You can also visit our virtual booth, contact us, visit our website, and yeah, I hope we will cooperate together. Thank you very much.
Thank you so much, Piotr, for a great presentation. We've got a couple questions coming in. Just as a reminder for the folks on the line, please enter your questions into the Q&A box. I would love to start with a question related to some sessions we had yesterday about existing stores. Just curious, this seems to me like a great potential solution for an existing supermarket. Could you talk a little bit about if the CO2 units can be installed in an existing supermarket and what the remodel process would look like, if so? Okay, this one I will answer. For sure, it is possible. We've got experience in installing our CO2 systems in existing supermarket with remodeling. Of course, if we replace the HFC installation and if it's with low PS, we need PS pressure. We need to replace the whole system, including the whole installation, whole piping, every components and evaporators as well, to change it for the required PS pressure for the CO2. But what is very important with our decentralized solution is that we can make this remodeling without closing the shop, with the business keep going on. Because as I said, with our CO2 decentralized solution, we can divide the whole cooling demand into the bigger quantity of smaller, let's say, installations. And we can make this remodeling step by step. We can cut some part of the section, move the storage goods to some other part of the shop, and then connect this cut section to the new CO2 units. So we can do it step by step. And this is our experience that it is possible. And we know that it is very important, especially for the final customers, that we enable to do this remodeling with possibility to keep the business going on without the need of losing some business, some money, and so on. Great, that's wonderful. I also would love to dive in a little bit more on your heat recovery solution. If you could explain a little bit more about why that heat recovery is such an energy efficient option, and talk a little bit more about, how that all works and what the benefits of it are.
Okay, thank you for this question. Let me answer for it. Yeah, as it was highlighted on the presentation, our heat recovery system is really complex. I mean, this is complex system in compact units, because normally in such small capacity units like we produce, I mean, in case of CO2, this system can be simple and poor even, yeah, because we can have only the pipe connection to build the system on ourselves. Here, in case of area cooling solutions, we have a complex system which include the freeway valve, plate heat exchanger, and the controller, which maintain the proper conditions for heat recovery. We can reach even 51,000 BTU in such in this unit, and only one thing which will be needed to done by our customer is connect two pipes with the glycol to the system. So it means that on site we don't need to make build so big installations because it is included in our housing of the unit.
Great, thank you for that explanation, Patrick. We have another question about what your lowest temperature applications are.
So maybe I will answer for it. First of all, I want to highlight that our unit, for example, ICOL 51 BTU unit can be empty and LT. You can decide on site what will be the level of the temperature, I mean in case of evaporating, but we can operate even minus 31 Fahrenheit in case of evaporation. So this is quite low and suitable for low applications.
Great, thank you. Another question came in about some of the resources available within Area Academy. The question is whether Area Academy provides any guidance on code requirements for A2L refrigerant charging system design.
We plan that kind of article and material. It's not published yet because I need to say that Area Academy is quite a new thing on the market. We are developing it since 1 year, let's say. So it's not available yet, but we plan that kind of the material. But what I can tell you is that I invite you to contact me directly. And because one thing is that we publish materials, but second is that we are available to support you anytime. So if you've got that kind of need, please contact me and we can prepare that kind of information, that kind of material, and of course then make it faster to be published and share with you as well. So yeah, we see our role as Area Academy to meet that kind of demand. So yeah, please feel free to contact us.
Great, and last question, which is related to that, is how in Europe, as you've rolled out these units, how have you helped to prepare the service workforce for the installation and maintenance of this technology, and what kind of training resources would be available for technicians?
But you ask for Europe, our experience, how we do it?
Yes.
Okay, so yeah, we provide full required information with our units. I mean, the full documentations, some checklists, instructions, and so on. So it's kind of basic stuff. But as Academy, we also provide the videos with a startup process of the ICOL CO2 unit. So on every our ICOL unit which leaves the factory, there is a QR code which you can scan on site and jump right into the videos with guidelines how to start up the unit. And what is more, we organize the trainings. We've got both hands-on trainings in our factory where the contractors come to us. We organize 2-day sessions including both some theory about the CO2, but the most interesting part of these trainings is that every participant is doing the hands-on exercises and learning how to make the commissioning, the startup on his or her, of course. And we also organize the virtual trainings where we share some materials. So yeah, I think that the whole process of support to help customers, contractors starting up these units is provided by us. What is more, our R&D engineers, like Patryk, he can say even more about it, sometimes can participate in the commissioning, especially the first ones, and help the contractors to make this transition to this technology. And later they are able to do it on their own. So yeah, I think that we provide a lot of support in this matter.
Wonderful. Well, I know we're out of time, so I just want to thank all of our presenters today, Patryk, Piotr, Diego, Roman. Thank you so much for taking the time to tell us about your natural innovations. Thanks to the folks on the line for participating. And again, if you have any questions, feel free to reach out to our speakers directly or contact them through their sponsor booths. Thank you so much, everybody, and have a wonderful rest of your day.